Two statements are said to be logically equivalent when they have the same logical content. The simplest example of two logical equivalent statements are statement B and its double negation. In fact, if B is true or false, then so it is double negation and vice versa. It is easy to check whether two statements are logically equivalent by using truth table. Two statements are logically equivalent when their true values are identical, or the biconditional statement is a tautology. Notation for logical equivalent is this.
A truth table summarizes all possible true values of a statement. P can be either false or true. True value of P. 1 denotes true statement and 0 denotes false statement. So, this is the table that we need to memorize to solve truth table. Next, I will explain about negation, disjunction, and conjunction. Negation is an opposite true value from the variables. Next one is conjunction, used to combine any two primary statements to form compound statement. If either one of the statement is false, then automatically it is false. Disjunction, used to combine any two primary statements to form a compound statement. If either one is true, then automatically it is true.
Okay, next, I already explained about conditional statement. In conditional statement, you have three conditions, which is converse, second is inverse, and third is contrapositive. So let's go through one by one. Okay, converse. What is converse? The converse statement is obtained by interchanging the antecedent and the consequent. Next, inverse. What is inverse? The inverse statement is obtained by negating the antecedents and the consequent. And the last one is contrapositive. What is contrapositive? The contrapositive statement is obtained by both negating the antecedents and the consequence and by interchanging them. Okay, next, I will explain how to write the statement in the symbolic form. So, the general statement that we have here is, if you stay, then I leave. So, P is the antecedent, Q is consequence. So, P, where we can get it, we can get it after if, and the Q after then. So, P will be you stay and Q will be I leave. So, the symbolic form is P implies Q. So, next, converse. Symbolic form for converse will be Q implies P because we interchanging them. So, the statement will be if I leave, then you stay. So, next, for inverse, it will be the symbolic form, it will be not P implies not Q because we negating the both antecedent and consequent. So the statement will be, if you do not stay, then I do not leave. So the last one is contrapositive. Contrapositive, the symbolic form will be not Q implies not P because we negating both antecedents and the consequent and interchanging them. So the statement will be, if I do not leave, then you do not stay.
Okay, without wasting any time, let's take a look at this question. In the following statements, write the contrapositive, converse, and inverse. Okay, let's solve question 1A first. If it is raining today, then I will not go to school. So, the first step is we need to identify where is the P and where is the Q. So, for this question, P is it is raining today and Q is I will not go to school. And then we'll write down it. Okay, P is it is raining today and Q is I will not go to school. Okay, so we need to know the not P and also the not Q. Not P is it is not raining today, and then the not Q is I will go to school. Let's do the contrapositive first. So for this question, if it is raining today, then I will not go to school. The symbolic form will become P implies Q. So contrapositive is we change the position and also put the negation. So the symbolic form will become not Q implies not P. So the sentences will become, if I will go to school, then it is not raining today. Okay, let's continue with converse. The converse is we change the position, so the symbolic form will become Q implies P. So the sentences is, if I will not go to school, then it is raining today. Okay, let's continue with inverse. The symbolic form for inverse is not P implies not Q. So the synthesis will become, if it is not raining today, then I will go to school. Okay, done for question 1A. Next, let's take a look at question 1B. This flower will bloom if we water it. So we need to identify which one is the P and which one is the Q. In this question, the P is we water it and the Q is this flower will bloom. We water it and the Q is this flower will bloom. Not P is we do not water it. Not Q is this flower will not bloom. Okay. So the contrapositive is still the same. The symbolic form will become not Q implies not P, and then the synthesis will become we do not water it if not Q is this flower will not bloom. Okay, so the converse is still the same too. Change the position and then the symbolic form will become Q implies P, and then we write down it. We water it if, and the Q is this flower will bloom. So let's do the inverse. Still the same. And the synthesis will become this flower will not bloom if we do not water it. Okay, so let's continue with 1C. If it is rainy, then I will carry an umbrella. Still the same. Identify where is the P and where is the Q. So this question, P is it is raining today and Q is I will carry an umbrella. Not P will become it is not raining. Then not Q is I will not carry an umbrella. Okay, let's do the contrapositive. Not Q implies not P, and then the synthesis will become if I will not carry an umbrella, then it is not raining. Okay, let's do the converse. Change position, Q implies K, and then Q implies P, and the sentences will become if I will carry an umbrella, then it is raining. Okay. The sentences for inverse is if it is not raining, then I will not carry an umbrella. Okay, therefore this question. Okay, let's look at this question. I work extra hours only if I get extra income. Find inverse of converse and contrapositive of inverse. So, how to solve this kind of question? So, the right way to solve this question is from right to left. For example, like question A, inverse of converse. First, we need to do the converse first, and then after we converse, and then we will do the inverse. And that is the final answer for this question. Okay, let's do this together. Okay, we need to identify which one is the P and also which one is the Q. So from this question, P is I work extra hours, and Q will become I get extra income. And then let's write down it first. The symbolic form for this question is P implies Q. So the question asks for inverse or converse. Let's do the converse first, and the converse will become Q implies P, and then the sentences will become I get extra income only if I work extra hours. Okay, so from here we need to do the inverse. Symbolic form for inverse of converse is not Q implies not P, and then the sentences will become I do not get extra income only if I do not work extra hours. Then for question A, let's take a look at question B, contrapositive of inverse. So we need to do the inverse first. Symbolic form of inverse is not P implies not Q, and the sentences will become I do not work extra hours only if not Q is I do not get extra income. So from here, symbolic of contrapositive of inverse is Q implies P, and the sentences will become I get extra income only if I work extra hours. So this is the final answer for this question.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Amir Debi Muhammad Azari. Today I'm going to explain to you guys about how to determine whether equation is equivalent or not. So by looking at this question, which is Q or not P and not Q equivalent to not P or Q, how do we determine this question? By using truth table. So how do we start? The first way to start is just we could memorize it. So P and Q, so we need to memorize it start with 0, 1, 0, 1. Otherwise P gonna be 0, 0 and 1, 1. So this is fixed, so you guys can remember this. So not P gonna be 1, 1, 0, 0 because it is the difference of P. Not Q gonna be 1, 0, 1, 0. So at this moment we fix the PQ, not P and not Q. Now we look at P and not Q. So we look at N. The P and not Q need to be the same number, 1, and it's gonna be 1. So we search for it, P and not Q. So it is 1. they are in this area. This is 1. The others is not 1. So it's going to be 0, 0, 0. Next, we look at the question. We see the question, it is not P and not Q. So what I'm going to do is by putting A here. So we know this is A. And then we're going to make it not A because A is this equation. So not A is the difference between A. So it's going to be 1, 1, 0, 1. So from the equation, we see Q or not A, right? So we put it not A here. So Q or not A. At least if it's 1, then the other going to be 1. So Q and not, so this is 1, this is 1, this is 0, and this is 1. Next, we look at not P or Q. Again, it's R. At least 1 at the equation, then the algebra then is going to be 1. So we look at not P, so 1, 1, not P is 0, Q is 0, so it's going to be 0 and 1. By looking at these last 2 columns, we could see that the number is the same. So from this, therefore, Q or not P and not Q are equivalent to not P or Q, since the corresponding column are identical. So the number is the same, so it is logically equivalent. Thank you.
We move to the conclusion. We can prove that logical equivalence is when 2 statements have the same true value, or the 2 statements are provable from one another. Logical equivalence is necessary because tautology and contradictions are essential in proving or verifying mathematical arguments. It helps us to explain propositional equivalence.